Ladies and gentlemen, before we start our class, please do put your mobile phones or laptops on a table. Grab a notebook and a pen and take down notes. Please. Sikinabi.
Hello guys! So welcome to our first meeting of Mechanics of Deformable Bodies. And for this day, we will first deal with the overview of the mechanics of deformable bodies. And for our first lesson, we will talk about the definition of the mechanics of deformable bodies. So, what is mechanics of deformable bodies? Let us first know what should be our outcomes for this lesson. So first, you should understand and define mechanics of deformable bodies. You should identify the different kinds of external loads and supports, which we have already discussed that one on our statics of rigid bodies. And we have to review equilibrium equations. And lastly, we should review the different internal loadings in the body. Okay, so we have a lot of things to review, and I guess madali ranin nato kay review raman eh, di ba? Okay, so let us first define the mechanics of deformable bodies. So it is actually a branch, di ba? Atong sa atong statics, nag-discuss ko at our first meeting daghan og branches ang engineering mechanics. And one of its branches is mechanics of deformable bodies. So this is actually a branch of engineering mechanics, and it studies the internal effects of stress and strain in a solid body when subjected to external loadings. So when we talk about mechanics of deformable bodies, we are dealing with the internal reactions of the body that you are dealing with. On your statics, as you can remember, we have dealt with the external forces that we have applied on the body. But now, we will talk about the internal reactions of the body that is subjected by external forces. Okay? So, yung ana lang. So now, let's have a review on the different loads that is applied to your body. So first, naatay external loads. Diba? Na review naman nato sa statics ang external load. What are those external loads? We have first surface loads. So surface loads are caused by direct contact of one body to another. So for example, I am putting a load from my hand to this object. This is a surface load because I am applying a load in contact to the other object. Surface forces can also either be concentrated force or linearly distributed force. As you can remember, dito sa atong statics, there are two kinds of surface forces. Diba sa una sa atong mechanics, we have a beam. And naay mga forces nga gi-apply ang beam. One is a concentrated load, which is, as you can remember, it is only applied at a single point, right? And we also have a linearly distributed load. It can either be a rectangular load or a triangular load, depending on what kind of load it should be. Okay, so naka-remember mo ana. And to get the resultant force of this kind of loading, all you have to do is to get the area of it. Nga na lang, saan yung atong square o saan yung atong triangle, nga rectangle, whatever. Okay? So, ing ana lang. Now, let us proceed. Another kind of external load is body loads. And usually, you can imagine it, there is an attraction of one body to another. There is always an attraction, especially if that body has a very large mass. Okay, so say for example, ang Earth, naay attraction ng Earth sa ato. So we are attracted to the Earth with the influence of gravity. So, ang kana nga kind of load that is body force, because these bodies are not in contact, but they are reacting with each other by forces. Okay, so naa sila attraction, and that attraction is caused by gravity. Okay, ing ana lang atong body forces. So we have surface force and body force. So sayo na to kayo i-review. Now, let us review to some of the support reactions that we have dealt with on our statics of rigid bodies. I guess there are 6 of them, and we will tackle each of them one by one. Again, sa ganun ng mga support reaction are actually surface forces, and they are developed at the supports of a body. Okay, and they are reactions. So, naa siya sa support sa body. So, usually, naa siya sa mga end sa ng atong mga body. Usually, makita na nato sa beams. Okay, let us try to remember what are those kinds of support reactions. First, we have a cable support. Sa ganun ng cable support, for example, we have a beam that is tied by a cable. So, mao na atong cable support. So, how are we going to make a free body diagram of a cable? So, ato lang i-drawing ang beam, and then, unsa man direction sa force? The direction of the force is actually the direction of the cable. Okay? And it should always be in tension. Ana lang. We also have a roller support. Unsa man ang roller support? I have an example here of a roller support. And unsa man ang reactions na lang naa diha? Ang ato lang reactions diha is ang force going perpendicular to the surface of where it is supporting. Okay? And next is a smooth support. So when you have a smooth support, it is also the direction of the reaction should also be perpendicular to the surface where it touches. We also have an external pin. When you say external pin, kadong naibutang nga pin para i-attach. Okay? So this one actually will restrict both the x and y directions of the forces, of the force that is reacting to the beam. Also, we have an internal pin, which is the same of your external pin. They restrict the movement of your member on the x and y direction. And lastly, we also have a fixed support. And usually, we call fixed support as cantilever beams. Why? Because nagbitay lang siya. Usa lang ka end ang simentuan. Ato lang isulti simentuan. And it restricts, unsa man, our x direction, our y direction, and our moment. Okay? So it restricts the movement of the beam on all its reactions. Okay? So ingana lang ang atong mga types of reactions. Cable, roller, smooth support, external pin, internal pin, and fixed support. Got it? Got it. Because this is, again, a review. So, now, let's have a review of the different equilibrium equations. Diba, ang importante kayo ng equilibrium equations when we are dealing with mechanics of deformable bodies. Why? Kaya ang atong goal sa atong mga building nga dapat dili siya mulihok. So, in order for these buildings to not be moving, then we should always satisfy the equilibrium equations. Now, what are, again, those equilibrium equations? We already have known that the very common equilibrium equation, which is the summation of forces, it should be equal to 0. And also, the summation of moments should be equal to 0. So, umuo lang na itong mga equilibrium equations. So, if we are going to dig this one deeper, then makahibaw mo nga dapat, kung ma-0 siya, dapat ang x, y, z components of these forces dapat ma-equate into 0. And also, ang x, y, z nga moments should also be equal to 0. So, remember mo, summation of forces along the x ta equals to 0, summation of forces along the y equals to 0, summation of forces along the z is equal to 0. Okay? So, ingana lang. And we have summation of moments of x, y, and z. So that's just a review. And I guess you already know how to do it, how to deal moments. And you already have obviously known how to sum the forces along with their respective components. Okay? And next is, let's have a review of those internal loadings nga tanan internal loadings nga naa sa atong body. Okay, let's have a review with that because that is very important as well. Okay, labaw na karon kay internal loadings man atong i-deal sa strength of materials. So, we have a body that is, so imagine we have this body, and this body is subjected to 4 forces. Okay? Okay, so we have this body that is subjected to 4 forces. And now, try to imagine that I am cutting this body. I am sectioning this body at this axis. Maningana na siya. Mitochondria is the powerhouse of the cell. But anyways, so we have exposed this section. And sa pag-expose na to nga section, we can also see the different forces or the different internal reactions that is occurring inside this section. Okay? So, now, after we are going to section this one, we can actually get the resultant force of these forces. Right? So, let's say, ato ni siya giad tanan. And then, it results nga bali ang akong directions of force. It should be going in this way, okay? So karon, ang ato kuntay force padong dira mo ni atong resultant force. And then these are just delta Fs. Kaning mga gagmay, mga delta Fs na sila. Okay, so basically, Fr is just equal to the summation of your delta Fs of these small forces. Okay? Sige. So, karon, equilibrium equation says that if you sum this one with this 2, it should be equal to 0. Okay? So, let's call this one siguro F1 and call this one F2. So, summation of forces, so Fr should be equal to F1 plus F2. Okay, again, kuan man ni siya, internal force sa diri sa atong duha. Okay, so, and we know that this one is in equilibrium. Then, we can also get the moment. Wala na dyan okay ba kung unsay direction sa moment ha. Pero, let's assume that mao na yung moment ana. So, you can remember sa atong statics that if we are going to section a beam, we can expose its internal forces and the moment at that point. So, mao po niya ang nahitabuan ni dire. I-expose na to ang internal force and then nakitaan po na to ang moment. And actually, again, this internal force is just the sum of all these very small mga forces. Okay? So, ang ana lang. Now, for slender materials, para mas sayo ng atong pag-imagine sa atong kahimtang karon, libog man ng 3D, para mas sayon, let's go to 2D. And let's deal again with beams. Okay. So, di ba, nakahinomdom mo nga, sige, fixed support, ay kanang ko, dili siya fixed support but simply supported beam. So, for example, so I am putting a force going at that direction. And I am sectioning the beam at this line. Sa may mahitabuan na. Diba? Ang una na tong buhaton is to determine the support reactions. Diba? And then, mag-section na ta, and then ma-expose na to ang kaning nga section. And then, makita na to diri ang internal reactions. Fx, Fy, and probably there is a moment nga na diri. Diba? Naka-remember mo ani? I hope you did because this is very important. Nga na gyapon ang atong concept sa atong pag-sectioning diri. So, let us review all those reactions, internal reactions nga nahitabo diri sa atong beam. Diba? Nakahinomdom mo nga naghimo ko og shaft sa una. And then, naatay mga reactions butang sa atong axis. So, this is your X, this is your Y, and this is your Z. So now, as a review, if this is your shaft, and if the force is going in this direction, makinomdom mo, unsa gani ni? This is your normal force. Normal force. Take note, normal force always go perpendicular to your cross-sectional area. This is your cross-section, kaya ako manigipotol. This is your cross-sectional area, and your normal force is going perpendicular to that area. If the force is going parallel to the area, so, mo ni atong area, unya ang atong force kay going parallel to it, then this is what you call shear force. And actually, we have two shear forces. Why? Naata diri sa, and this is denoted actually as V. Vx. Vx ni siya kay going at the x direction man. We also have going at the z direction, which is your Vz. Okay? So, this is your force going at the y direction, which is perpendicular to your cross-sectional area and parallel to the longitudinal axis of your shaft, that is your normal force. If you have a force that is parallel to your cross-sectional area, that is your shear force. Take note, parallel to the cross-sectional area, shear force, perpendicular to the cross-sectional area, normal force. And now, if you have moments, and the axis of your moment goes perpendicular to your cross-sectional area, you call it torsion. Or Ty. Thank you. So, for example, this is your shaft. Ako siya lubag og paing ana. Nag-apply kog moment at this direction. Okay? Nag-apply kog moment at this direction. So, kung nag-apply kog moment at that direction, I am applying torque to my shaft. Okay? Again, mao ni ang direction sa imong moment, and then mao ni axis sa imong moment, and your axis is perpendicular to the cross-sectional area of your shaft. Okay? Now, if atong moment is applied on your x and z axis, which is this axis and this axis, kung ako gi-apply aning mga axis, nagbutang kog moment, murag ako siya giing ana, nagbutang kog moment paing ani. Unya, unsa may kuan ani, unsay tendency ani nga mahitabo? Mo bawg siya. Okay? Di man siya mo bawg kay wala ko'y gamiton. And that is what you call bending moment. Okay? So, your moment is applied on the x and z axis when you are talking about bending moment. But when you are talking about torsional moment, it is applied on your y-axis. Okay? Take note because that is very important. Okay, so let's have an example. And this is also a review of your statics nga mga problems sa una. So, example number 1 is to determine the resultant internal loadings that is acting on the cross-section at C of this beam. Okay? Of this cantilevered beam. And as you can see, we have a triangular loading. So, unsa gani una natong buhaton sa una, ato i-drawing ang beam. Okay. And when you are going to draw the beam, you should also expose all those forces nga naa dira sa atong reactions. And since we know that this portion here is a fixed support, then we already know unsa yung mga reactions ang naa nga fixed support. Unsa man ni? X. Pero we know that this wala ni siya X nga component kay ngano man all our forces are going downwards. So basically walay mga X component aning atong force. So ma-zero ra ni atong X. So Fx equals 0. Naapod tay Y. We already know nga naay Y kay na may Y nga forces. So Fy. And important, naapod siya moment. Moment at point O. So, mo na ang atong mga forces. But, ang atong goal is to know the internal reactions at C, which is 3 meters from the wall. Okay? Sige. So, let's try to answer this one using a blue pen. Okay. So, first step is to determine these support reactions. And again, we already knew that the force along X is equal to 0. Kay wala man tay X components. Diba? Dito sa Y, summation of forces along the Y. So, kung dito sa Y, let's assume the positive is going upwards. So, Fy minus pilang area ani nga kuan? This is 270 Newton per meter. And since we already know that this one is a triangle, unsay formula sa triangle? Base times height over 2. So 1/2, what is the base? Base is basically the length of this beam, which is 9 meters, times the height of this component, which is 270 Newton per meter. So, cancel. And we know that Fy is just actually equal to 1,215. So, this one is actually 1,215 newtons. Okay? Ganyan lang siya kasayon. And, let's go to the moment. Patanahuman, ato sa moment, summation of moments at point O. So, the direction nga atong gi-assume is going there, so ato ibutang going there as well. So, this is MO, and positive atong MO kay padong siya paingana, pero naman ta nag-moment ta dire, so ang kaning atong triangle is negative. Minus the area or the resultant, which is we already know, 1,215 newtons. And sa paman, moment arm. So, unsaon ganitong moment arm? Unsa ganitong rule na to sa itong moment arm? So, mao ni atong triangle asa ang centroid along the x-axis sa atong moment arm. It should be 1/3 from the highest part of the triangle or 2/3 from the lowest part of the triangle. So, since this is 9 meters, so 1/3 of 9 is 3 because 1/3 dire. So, dire man ta nag-moment, so dapat itong moment arm from here to this point at the centroid of the triangle, which is 1/3 of 9, which is 3. Okay? Ato lang ibutang dire 9/3 para makakuan mo meters. Okay. So, this is equal to 0 as well. Okay? Equilibrium man ni siya. So, ato i-calcio 3,645. 3,645 Newton meter. So, that is your moment at point O. Pero, Di pa na final answer ha. Okay? Ang atong gipangita, ang internal reaction at point C. So, wala pa tanahuman. So, Fy equals to 1215 and then MO is equal to 3645 Newton meter. So, let's continue. Now, diri na ta sa atong gisection nga portion. Okay. So, since we already know magbalik tag free body diagram and karon ato na siya gisection karon. Wala man ko red nga kuan. Ato na siya gisection diri. Okay, nag-cut na ta dira. We can either choose this portion or this portion. But for this example, I will just choose the left portion. Okay, nag-solve man ta sa support reaction. Pero kung na ato gipili ang right portion, we don't have to solve for the support reactions. Okay? So, okay, let's draw it. And we already know, cut na, this is 3 meters. And we have a known y, x, and moment. So, this is cy, this is cx, and this is mc. Okay, so we already know the support reactions at here. Unsa man ni? This is 1,215 newtons. And we have moment of 3,645 newton meter. Again, wala natay x kay zero man ang atong support reaction nga x. So, zero po na dire. So, zero jud ang sa whole. Okay? So, karon ato pangitaon ang cy og mc. So, to get cy, what are you going to do? Just sum the forces at y. Ano lang. And assume that the direction of your unknown is the positive direction. So, cy minus 1,215 newtons is equal to 0. So, basically, sakto ba? Wala pa di ay. Beshime, wala pa di ay naman Beshime. So, this one is 3,645 newton meter. And then, napatay triangle di ay. Wa na to na-appeal og account ang triangle. So, unsa man ni siya? 270 ni siya nga portion. Unya, unsa naman siya diri nga portion? Ha? Mag-ratio and proportion pa ta. So, kay, di ba, ang height ani kay mo man 270. Pero what is the height at this point? So, mo na atong gamiton og ratio and proportion. Or, actually, we are using the slope method. So, unsa man tong slope? Di ba, ang slope is rise over run. So, ato ikuan ang rise over run. 270 over run of 9 meters is equal to, because same man sila slope, so, wa man ta kibaw sa height ani, so ato na siya ibutang x, and then, kibaw man ta sa length ani, which is 6 meters. So, x is equal to, pila man na. So, this is 180 Newton per meter. Ay nanawag. So, now we already have solved for the x. And again, this x defines the height of this line, which is 180 Newton per meter. So, nakibaw na ta nga 180 dahil ni Newton per meter. So, ato ni appeal og account sa atong summation of forces along the y. Diba? Mo na ito nakalimtan, mo itong naglibog ko kaganiha. So, ato i-add, plus. Nganong i-plus man nato because it is going on the direction downwards. Okay? So, ato siya i-divide into 2. Okay? Maglibog man ta og solve kung yung ani, kay it is a combination of triangle and rectangle. So, ato siya i-divide into 2. Triangle or rectangle. So, ato unahon og kuha ang triangle. So, saan man ni? Base times height over 2, di ba? Height sa triangle, which is 270 minus 180. Base sa ta, base is 3 meters times height, which is 270 minus 180, which is 90. Sakto? 90 Newton per meter over 2. So, maoni ang area ani. Okay? And lastly is the area of the rectangle, which is, kibaw man ta nga 180 ni, so 3 meters times 180 Newton per meter equals to 0. And then we can now solve for Cy. So we have here 540 newtons. So ang atong Cy di ay is 540 newtons. So mo natin pangita. Nya, kibaw man ta, again, ang Cx is equal to 0. So ato gyapon ni apil kay apil man sa check. Okay. And lastly, ato gipangita ang MC. Para makuha natong MC, magmomenta at this point. So, summation of moments at point C, and assuming that this direction is the positive one, so the positive equals to MC minus, ato unay-unahon, 1,215, di sa ko magbutang unit kay para mag-save tag space, times moment arm of 3 meters. Diba? Unya, ato pa ni account, plus 3,645 Newton meter. Wala na ako ibutangan og unit again. And, kani, unsa naman eh? Plus ni or minus? Plus, ato na po ni kuha ng area. So, ato gyapon i-apply ang same gyapon nga ato gibot kaganiha nga gi-divide nato ang triangle o rectangle para di ta maglisod. Ato unahon ang triangle. So, sa to 3 times 90 over 2. Mao ni ang force. Mao ni ang force. Ang moment arm, kung sa ganito i-rule sa moment arm, 1/3 from the highest to and 2/3 from the lowest. So, since 3 meters man eh, kaganihan 9 meters man to, kaya ang whole man to, pero kani 3 meters naman lang ni, so what is 1/3 of, what, diri man day gikan padong, diri sa centroid sa atong triangle. So, 2/3 from the, sa pa ni? 2/3 from the smallest part of the triangle, which is 2/3 of 3. 2 meters. And last, sa kani atong rectangle na pod, nindot na kuan, plus. So, since rectangle naman siya, to get the area, base times height. 3 times 180. Diba? Kay 180 ang height, and then ang base kay 3. And then, ang moment arm, kung sa ganing moment, sa ganing centroid sa atong rectangle, it should be at the center. So, what is the center of 3? 1.5. Okay. So, makuha na natong MC by shift solving. Diba? Taas atong solusyon, no? So our moment at point C is negative 1,080 Newton meter. And since nganong negative man eh, kaya atong assumption it is going counterclockwise. So, the actual DI is 1,080 Newton meter moving clockwise. Okay? So, these are the internal forces of your section at point C. Number 1 pa ta. Kapuya mag-maestro. Okay. So, let's proceed to number 2. Number 2 has the same concept, but now we have a bar that is supporting your beam. So, all we have to do is also to determine the resultant internal loadings acting on the cross-section at C of the beam. So, again, we have this point C, and we are going to section this one. Anong na naman po yung triangular loading? Ay, ano ka rin ako pipili ng example? Sige, let's do this. Let's be patient to ourselves because life is hard. Kailangan tag-sweldo. We need money. Unsa na nato buhaton? Again, the first thing to do is to draw a free body diagram. So, ang ato nang i-draw karon kay ang atong gi-focus nga object or ang body, which is ang atong beam. Focus lang ta sa beam. And then, we are going to show all the external forces that is acting on this beam. What are those external forces? You can see on point A, we have a pin support. What does that mean? It only supports the X and Y components of your beam. Okay? Y and X. Okay? So, let's call this one AY and AX. You also have a triangular load. And we know that the maximum load is 300 pound per foot. Morning intensity sa pinaka taas nga portion. And we also have a beam that is supporting from this point to the wall. So, ang atong ibutang diri, ang atong i-account lang kay ang direction sa atong beam, which is 30 degrees. And the problem is we still don't know sa magnitude ani. And let's just call this one as FB. How are we going to solve this one? We have three unknowns, right? We have we have two unknowns on the right support and we have two unknowns on the left support. So, unsa man nato be? Let us test your mind if how are we going to solve this one? Unsa nga equation ang atong gamiton? Well, the equation that we are going to use is moments. So we should use summation of moments in this one. Now, asa man ta mag-moment? Ganahan ko mag-moment kay para nay usa nga unknown mabilin. So, therefore, dapat mag-moment ko at this point here. For me to be able to cancel my forces at AX and AY. Okay? And therefore, ibilin nato ang atong FB. And we will be solving for FB. Okay? Sige, let's do this one. So, summation of moments at point A, assuming the direction of your unknown FB is positive, which is that way. Saan man na to? Diba? Maglibog man ta kung ato ni siya ay consider as this force nga padung siya dito. Wa man ang ato ba ang goal para sa tong moments is the force and its moment arm. So, kung maghuha pa ta sa moment arm, dapat pa ta makaibaw ani nga length. Kaya diba mao man yung perpendicular, dapat ka makaibaw ani nga length, which is much hassle. So, we have a technique I've taught you before that we can use the components of this force. So, therefore, we have FBX and FBY and FBX. But since we already know that your FBX is not included with the summation of moment, why? Because your FBX actually will igo your point of moment. That's why ang mabili na lang nato nga force is your FBX. Okay? So, let's solve this one. Summation of forces at point A is equal to, again, FBX and, Ato gipangita kay FB man, di ba? So, ato kuhaon FB, unsa man ni? Sin 30. So, mo na atong FB. And then, ang atong moment arm is, sa moment arm? 10. So, 10 meters. Meters, feet. So, this is our FB sin 30 is your force, your vertical force, your FBY, and your 10 feet is your moment arm. Diba? Perpendicular. So, muna. And then, sa pala na to i-account nga force. Kani nga force. So, dapat ato na include. So, unsa may effect ani niya sa moment, atong positive should be going clockwise. But this one, this create a counterclockwise direction. So, we should minus this one. And, kuha ta sa force ani, which is basically the area of your force. So, 1/2 times base, which is 6. Ang base ani, 6. So, 6 feet times height of 300 pound per foot. Napabatay lain kuwang kaniraman ug kani, so equals to 0. So now, let's solve for FB. Is equal to, gigutom na ko. So basically, the answer of your FB is 180. So, therefore, the magnitude of this force is 180 pounds. Oh my gosh, ka na pa ito na-solve? Kahasol ba? Since, natay technique. Since nag-section man ta at point C, so di na ta nag-section, and this is actually 2 feet from the end at point B, pwede na nato igamit. Pwede ra ka na ang atong basihan sa atong pag-solve. Okay? We can either choose the left, or the right of the kuan. Sige, so magtinapulan ta karon. Dili na ako mag-solve sa AX ug AY kay nakita naman nato tanan mga kuan dere. Okay? At buhaton. Sige. So, I am going to section at point C and then choose the left portion of this beam. Diba? Kay, again, moto, pwede ta makapili bisag asa. So, let's draw again the free body diagram at that point. And then, a section na siya. So, again, I have drawn this beam that is already sectioned, and this is actually 2 feet. And we already know that this force FB is 180 pounds. Maoran ni siya ang load diha nga point, and this is 30 degrees. So, nag-cut man ta diri, we have exposed the internal forces at this section. So, sa ito internal forces, CY, CX, and MC. Now, can we still assume that CX is 0? No. Why? Because we can see that this force has an X component and also a Y component. So, klaro na nga dili ni siya 0 ang atong CX. We should solve for CX as well. So, nani sila yung values ang kaning tulo. Karon, unsa ato unahon pag-solve? Ato unahon pag-solve ang CX. So, to solve for CX, we should sum the forces along the X. And assuming that the direction to the right is positive. So, CX minus ni, di ba? Kay padung man siya to the left, yung positive na to the right. So, 180, unsa man ni? Sine or cosine? Adjacent over hypotenuse. So, cosine of 30 degrees. Napabaylain? Kaniraman o kani ang atong forces is equal to 0, wala na. So, therefore, our CX is actually equal to 150 55.88 pounds. Box your final answer. Now, next, summation of forces along the y. Okay, summation of forces along the y, assuming again that the positive direction is going downwards. Kaya ang atong unknown is going downwards man. So atong positive going downwards na lang pod. Okay, so cy, since upwards man atong direction ani, so man, minus 180 sine of 30 degrees. Napabatay line account nga force, wala na, equals 0. So therefore, our cy is 90 pounds. Wa pa rin na ito nabutang og direction ani. Going to the right and going up. Going downwards. Nanatay duha ka answer. Now, how are we going to solve for MC? So, again, we are going to use the summation of moments. Summation of moments at point C, assuming again that the direction of your unknown is the positive direction. So, equals to MC. So, pamalan na to i-count ng forces. Kanira man. So, ato unahon ang, wala na may x direction. Wala naman tayo sa x. Kaya, di ba? Muigo gihapon sa moment at C. So, ato lang is ang y. Unsa may is y positive or negative? Ani ang atong positive direction, diri ta nag-moment, and this one goes opposite to the positive direction. So therefore, negative 180 sine of 30 degrees times the moment arm, which is 2 feet. So therefore, this is equal to 0 pa. Wala na tayo space, so ubos na lang. Therefore, your MC is just equal to, the answer is 180 pound-feet. Hoy, timan iha, ang unit sa moment is force times length. So, pound-feet and Newton-meter. Timan eh. Okay, masayop mo sa unit. Jugbong. So, since this is positive, then we can say that our assumption is correct. Therefore, it is moving, it is rotating counterclockwise direction. So, we have already answered all the unknown internal forces of section C, of point C. So, I hope you have reviewed on how to solve this kind of problem, which we already have solved this one in mechanics. So if you are still confused on how to solve this one, then I will highly suggest that you will review. Okay? It's very important. Review lang ta, Jod. Ay lang pagsalig sa akong lecture kay this is just a part of your learning. Okay? So, as a summary, nag-summary naman kung ganihan, no? For summary, we already have talked about the definition of mechanics of deformable bodies. We also have talked about the external loads, the different external loads and supports. We also have reviewed about the equilibrium equations, and we also have reviewed those internal loads nga important. And please, again, review, because those things are very important. And we also have solved some problems nga related to mechanics. And I hope you have learned something. I hope you have understood my lesson. And see you on the next episode.